Today's lesson is angles of polygons, and we are going to be talking about the interior angles and the exterior angles. So my learning objective for today is I can find the interior and exterior angle of polygons by connecting the formulas to a triangle. So let's start out with, if I have a triangle, I have three sides, and I know I can make one triangle. So the sum of my total interior angles is going to be 1 times 180 degrees, which is 180 degrees. So for a quadrilateral, a quadrilateral has four sides. So 1, 2, 3, 4. So I have four sides. If I draw in one diagonal, I have two triangles. So if I add up the angles from each triangle, I'm going to have 2 times 180 degrees, which is 360 degrees. For a pentagon, so a pentagon has 1, 2, 3, 4, 5 sides. If I draw in two diagonals from one vertex, I now have 3 triangles. So I have 3 times 180 degrees, which is 540 degrees. So if I add up all the angles in my polygon for a pentagon, they would total 540. For a quadrilateral, 360. For a triangle, 180. So for a hexagon, 6 sides, 1, 2, 3, 4, 5, 6, 6 sides. If I draw in the diagonals all from one vertex, I now have 1, 2, 3, 4 triangles. So the total number of angles is going to be 4 times 180 degrees, which is 720 degrees. So I could go on and on and on. So I want to set up a general formula. And I notice when I'm looking at these two numbers in every case, I see that the number of triangles is the number of sides minus 2. So 3 minus 2 is 1, 4 minus 2 is 2, 5 minus 2 is 3, 6 minus 2 is 4. So the number of triangles, however many sides I have, is going to be n minus 2. So however many triangles I have is how many I'm going to multiply. So I'm going to multiply n minus 2 times 180 degrees. So whatever number my polygon is, I have a general formula for interior angles. Okay, so just to review a couple things. N is the number of sides. Interior or exterior is what I'm thinking about. Do I have a regular or an irregular polygon? And write the equation. Make sure you're using an equal sign. I'm going to solve for what is missing, and then I'm going to substitute. Okay, so we reviewed already names of polygons. So again, n is the number of sides. These are the names of my polygons. So we already talked about interior angles. So the sum of the total interior angles, we just determined that formula. So this is n minus 2 times 180 degrees. So however many sides I have, minus 2 times 180 is the sum of all the interior angles. So each means if I have a regular polygon, I want to divide by the number of sides. So that would be n minus 2 times 180 degrees divided by n sides. So that would give me each angle for a regular polygon. So that means it is equiangular and equilateral. So these are definitions that we reviewed already. Okay, so let's go from there and then we'll get to the exterior angle formulas. So let's do a couple examples here. Okay, find the sum of the measure of the interior angle. So I'm talking about interior, so on the inside. So the equation is sum equals n minus 2 times 180 degrees. So if I count my sides, 1, 2, 3, 4, 5, 6, 7, 8, I know that n equals 8. So my sum is 8 minus 2 times 180 degrees, which is 6. So 6 times 180 degrees is 1080 degrees. So my sum, adding up all the angles, in my octagon is 1080 degrees. Okay, next one, find the sum of the measure of the interior angles of the coin for an 11-gon. So I know from the word an 11-gon that n equals 11 for 11 sides. So my sum is 11 minus 2 times 180 degrees. So my sum is 1,620 degrees. Okay, we're talking about angles, so make sure I have my degree measure to say what my units are. Let's try number 3. The sum of the measure of the interior angles of a convex polygon is 900 degrees. Classify the polygon by the number of sides. So classify says what is it in words. And I'm going to classify it by knowing how many sides I have. So my sum is 900 degrees. So I'm going to substitute 900 for my sum. And n minus 2 times 180. So I need to solve for n. So the first thing I want to do is divide by 180. So I'm going to divide by 180. After I divide by 180, I get 5. 5 equals, because 180 divided by 180 is 1, equals n minus 2. So I'm going to add 2 to both sides. So I get n equals 7. So I need to know what a polygon with 7 sides is. So when n equals 7, I have a heptagon. So my polygon is called a heptagon. Okay, so 7 sides is a heptagon. Let's try that one more time. I want you to pause the video and try this one on your own. All right, how did you do? So we'll start out with the sum of the interior measures of the interior angles of a convex polygon is 1,440 degrees. Classify the polygon by the number of sides. So my sum equals n minus 2 times 180. My sum is 1,440 equals n minus 2 times 180. So I want to start by dividing by 180. 180 divided by 180 is 1. 1440 divided by 180 is 8. Equals n minus 2. Adding 2 to both sides, and I get n equals 10. A 10-sided figure is called a decagon. Okay, so the classifying my figure is a decagon. So this is a decagon. Okay, let's try a little bit different. Okay, so number 5. Find the value of x in the diagram. So when I'm counting up, I see I have 1, 2, 3, 4 sides. So I know n equals 4. I have a quadrilateral. And we said the sum of a quadrilateral is 360 degrees. Okay, so we said if we have 4 sides, the sum of the interior angle is 360 degrees. Or you can calculate it again. So I know that the sum is 360 degrees. So I can set this up and say sum equals n minus 2 times 180. And we said n equals 4. So 4 minus 2 times 180. So my sum equals 360 degrees. Okay, so the sum is adding all my angles together. So now I can just set up and add up all 4 angles and set it equal to 360 degrees. So I can say x plus 108 degrees plus 121 degrees plus 59 degrees equals 360. So if I add all 4 angles, the sum is 360. Okay, so I want to combine like terms. So if I get x plus 108 plus 121 plus 59 is 288 equals 360 degrees. I'm going to subtract 288 degrees from both sides. And I get x equals 72 degrees. Okay, let's try number 6. Number 6 is a little bit different, but very close. So I'm going to start out with, I'm counting up my number of sides. So 1, 2, 3, 4, 5. So I know n equals 5. So the sum is going to be 5 minus 2 times 180. So I get my sum is 540 degrees. So what I notice here is these have the same number of arc marks. So I'm going to call those X because they're congruent because they both have 1 arc mark. So I can say X plus 93 degrees plus 156 degrees plus 85 degrees equals 540 degrees. So my sum is 540 degrees. So if I combine like terms, I'm going to add x plus x and get 2x. And 93 plus 156 plus 85 is 334 degrees. And that equals 540 degrees. So I'm going to subtract 334 from both sides. I'm going to add the inverse. So I get 2x equals 103. Let's see. 2x is 540 minus 334 is 206 degrees. Divide both sides by 2, and I get x equals 103 degrees. Okay. All right, so next, these are exterior angles. So these will be on the outside. So exterior is on the outside. So if I gave you a figure, and here are all the exterior angles, 1, 2, 3, 4, and 5. If I ripped all of these off and put them together, they'd form a circle. And the sum would be 360 degrees. And it wouldn't matter if I have 3 sides, 4 sides, 5 sides, any number of sides, the sum is always 360 degrees. All right, so let's do an example. So I'm looking in here and it's asking me to find the value of x. So I decide this is a exterior angle. So I know if I add all my angles, it totals 360 degrees. So I have x plus 2x plus 89 plus 67 equals 360. So I'm going to combine like terms. So x plus 2x is 3x. And I'm going to add 89 plus 67. So plus 156 equals 360. I'm going to subtract 156. So I'm going to add the inverse. So 3x equals 204. Divide both sides by 3. So I want to divide by the coefficient next to the variable. And I get x equals 68. Okay, we said that for a regular interior angle, if I want to know what each angle is, so when it's regular, I have all my angles are equal, so it's equiangular. So I divide n minus 2 times 180 divided by n. So in this example, it's asking me to find the measure of each interior angle for a regular octagon. So for an octagon, I know n equals 8. So substituting in, I get 8 minus 2 times 180 divided by 8. And I get each interior angle equals 135 degrees. I'm going to use the same process for the exterior angle. I'm going to take the sum and divide it by the number of sides. So we said for an octagon, n equals 8. So this is going to be 360 divided by 8, which is 45 degrees for each exterior angle. Okay, so what do I notice about the interior angle and the exterior angle? If I add them up, if I add up 135 and 45, I get 180 degrees, which is a linear pair. Which, if we think about this, if I add an interior and an exterior angle, I'm going to get a line. If I add an interior and an exterior, I'm going to get a line. If I add an interior and an exterior, I'm going to get a line. Okay, so let's go back and fill in the rest of these formulas. So we have a reference. So for my interior angles, n is the number of sides, n minus 2 times 180 gives me the sum of the interior angles. Each for a regular polygon is n minus 2 times 180 divided by the number of sides. We said for exterior angles on the outside, the sum is always 360 degrees. So each, which is 1, is going to be 360 degrees divided by n. So these are the 4 formulas I'm using. So I need to know, am I looking for an interior angle or an exterior angle? Is it regular or irregular? And what am I solving for?